Hello everyone, welcome to my YouTube channel Shivam's Classes. In today's class we are going to discuss problem number 4, 5 and 6 of chapter 6 and this is exercise 5.6. Alright, so we have already discussed problem 1, 2, 3 in the previous video. In today's video it will be for 4, 5 and 6. So let's start the class. So this is the first problem or the fourth problem. ABC is an isosceles triangle, right angle at C. Prove that AB square equals to 2AC square. So this is a very simple problem. First of all, let's try to make a figure. So this is my say right angle triangle. I have created a right angle triangle and this is my C because this is at right angle at C. So now call it A, B and C. So from Pythagoras theorem we know that from Pythagoras theorem we know that BC square plus AC square equals to AB square. Also it's given that ABC is an isosceles triangle. Prove that. So if it's an isosceles triangle, we know that only this side can be equal to this side. Hypotenuse cannot be equal to any other side. Alright, so if BC is equal to AC, we can write over here BC square and another BC or rather BC square also we can write again, and then we can write AB square, and then again we can write 2 BC square equals to AB square. We can as well write AB square equals to 2AC square. Alright, because BC equals to AC, right? So here itself you could have written AC square plus AC square instead of BC square and you would have got the result. So this is what we were supposed to get and we got it. Alright, let's go to the next problem. What is my next problem? My next problem is this one. Let's go to my next problem. The next problem is it's calling where ABC is an isosceles triangle with AC equals to BC. If AB square equals to 2AC square, prove that ABC is a right angle triangle. So again it's a converse of Pythagoras theorem, wherein we know that if in a right angle triangle, if let's say you have a right angle triangle like this, and your AC equals to BC, if we know that BC square plus AC square equals to AB square, we know that angle C is 90 degree, right? So let's see, if that being the case, then this implies this, right? So in this case what has happened here is that we have got AB square equals to 2AC square, right? And we can write 2AC square as AC square plus BC square, or rather let's do it in two steps. We can write it as AC square plus AC square, and since AC is equal to BC, so we can write AC square plus BC square since AC equals to BC. So now what we have got is AB square equals to AC square plus BC square. This implies that angle C is 90 degree. Alright, this is also a simple proof. This is a converse of Pythagoras theorem. Alright, now we can go to the next problem, which is this problem. So okay, in this problem what's being said is ABC is an equilateral triangle of side 2A, find each of its altitude. Alright, so let's create an equilateral triangle. Alright, so this is an equilateral triangle ABC, and now we need to find each of its altitude. So what it is saying here is that there is an altitude drop from here to here, here to here, and another one here to here. So these are altitudes, so D, E, F. So and then it's also given that this is 2A, this is also 2A, and this is also 2A. So with respect to symmetry, we know that if we find out one of these altitudes, the other altitudes will be also equal, right? So now let's try to look into this triangle ABD and ADC. So let's call this BD as X and then DC as say 2A minus X, because this entire length is 2A. So if this becomes X, then this will become 2A minus X, because when we sum it up it will be 2A, right? And then let's assume that the height AD equals to H. So from Pythagoras theorem we know that in a right angle triangle, in triangle say ADC, we know that my AD square plus DC square will be equal to my AC square, right? And AD square is nothing but let's call it P, just not to get confused. So we'll call it P. Alright, so we call it P. So P square plus DC square equals to AC square. And again, sorry, P square plus 2A minus X whole square equals to AC is nothing but 2A whole square. So this is 1. Similarly, if we go in triangle ADB, we can get AD square equals to AD square plus we'll get AD square plus BD square equals to AB square. Then AD square is nothing but P square plus BD square is nothing but X square, and then AB square is nothing but 2A whole square. This is my equation 2. Now I will put from 1 and 2. I'll use P square from here and put it over here, or in any way around. So I'll use a P square from here and put it over here. So I'll use P square as 2A whole square minus X square from this equation plus 2A minus X whole square, which is this part, equals to 2A whole square, right? This and this expression will go. So we have 2A minus X whole square equals to X square, and then we'll remove the square from here. So 2A minus X equals to X. This implies 2X equals to 2A. This implies X equals to A. We'll put X, the value of X over here, right? So what will happen here is we'll get A square plus P square equals to 4A square. This implies P square equals to 3A square. This implies P equals to root 3A square, which is nothing but root of 3A. So this is root of 3A. Similarly, this one will also become root of 3A, and this as well will come out to be root of 3A. Alright, so this is all we had to discuss in problem 4, 5 and 6. We'll discuss 7, 8, 9 in the next lecture. Thank you so much.